Let us solve this problem of solid circular shaft, which is subjected to both torque and bending moment. So this is quite a basic problem where we'll be having directly the values rather than the condition. So we have a bending moment of 3000 Newton meter and a torque of 10,000 Newton meter acting on the member. The shaft is having an ultimate tensile strength of 700 megapascal, and it is having an ultimate shear stress of 500 megapascal, and we have to assume a factor of safety of 6. So it is given that the bending moment, so it is M. The M that is acting on the shaft is 3000 Newton meter. I am converting it into Newton mm. So it is 3000 into 10 power 3 Newton mm. The torque that is acting on the shaft is 10,000 Newton meter. Again it will be 10,000 into 10 power 3 Newton mm. The ultimate tensile strength sigma u, which is the allowable value, is equal to 700 Newton per mm square. I am directly converting megapascal into Newton per mm square. And the shear stress that is acting or allowable, the allowable shear stress sigma allowable is equal to 500 Newton per mm square. The factor of safety is given as 6. So even though this is the value that is the material can withstand, we will be using sigma u by 6 as our value that we are going to take it as the working stress, and tau by 6 as the working shear stress that we will be utilizing in the formula. So since here we have both bending and torque, we will be using the equivalent bending moment and equivalent torque equation. So according to the equivalent bending moment condition, if you take the equivalent bending moment condition, we have to satisfy this equation. So according to this, the value of D is equal to 32 M equivalent bending moment, ME or MEQ, divided by pi sigma the whole power 1 by 3. And this is the equation. And according to equivalent shear stress or equivalent torque equation, according to equivalent torque equation or torque condition, D is equal to 16 equivalent torque divided by pi tau the whole power 1 by 3. So 32 is a numerical value, pi is a numerical value, sigma, right, sigma that we are going to use is sigma u by 6, which is 700 divided by 6. So we will get it in Newton per mm square. And M equivalent, the formula for equivalent torque, equivalent bending moment is equal to, so M equivalent, the equivalent bending moment is given by the formula half into M plus root of M square plus T square. So we already have the value of M, we already have the value of T. So substituting this in the formula, you can get the value of M equivalent. M equivalent is equal to 1 by 2 into the value of M was 3000 into 10 to the power 3 plus root of 3000 into 10 to the power 3 the whole square. You should be careful while taking the whole square, plus it is 10,000 into 10 to the power 3 the whole square. So this half is common for all, right? So simplify this and then divide it by 2. Now substituting this equivalent bending moment in the formula here, 32 M equivalent divided by pi sigma the whole power 1 by 3, you will get the value of D in terms of mm. This is for case 1. Now this is the minimum diameter that your shaft should satisfy, or the minimum value of diameter, so that the material will not fail when it is exposed to the condition, because the condition is given as 3000 Newton meter of bending moment and 10,000 Newton meter of torque. So for the given loads, the material should not fail, or the shaft should not fail. So it should have at least, so let us assume that you may have a 31.12, then you should not round it off to 31, you should round it off to 32, because you have at least 31.12 mm of diameter, so the material will not fail. Now going ahead with the second condition, that is your equivalent torque equation. Now the equivalent torque T equivalent is given by root of m square plus t square. So using this equation, root of m square plus t square, where these two values are already known, substituting it here, you will get the value of diameter in mm. Again, this is the minimum most diameter that you should satisfy, so that the material will withstand the shear stress that will be created due to the combined loading. So this combined load, both combined themselves and form have a nominal stress and a shear stress. So you should design your shaft for both the condition, and out of these two values, the largest, let me name it as D1 and D2, you have to take D1 if D1 greater than D2, you have to take D2 if D2 greater than D1. So this is your requirement, that is the minimum size of your shaft. So with the help of this, you will be able to solve problems where you have both bending and torque. So we will be also learning a few more problems where instead of we directly having the value of m and t, we will solve the given condition to find out what is the bending moment that is acting on the material and what is the torque that is acting on the material, depending upon the power and the type of loading. Thank you. Happy learning.